design and manufacturing and engineering I want you guys to kind of think about is if you're interested in sustainability, interested in how do we make better use of the resources we have, we're not going to stop making things. I guess it's a nice idea that we'll just use less, which I think we can, but that doesn't mean we make nothing. So how do we use less to either make the same amount or make sure people can have access to the same amount? And one of those things that you can do is just redo in the guts. You don't have to destroy the things you love, sometimes you just have to redesign them with less. And so that was kind of the project here. Made it seal better, made it last longer, made it with less parts, and less automated, so we didn't have to increase the price. People could still have the same thing they love, but we now did it with a lot less things. That's another kind of aspect of engineering. This is a factory. So actually a very nice factory it looks like. I spent a lot of my career traveling to China. I've worked in factories in the US, Mexico, China. And one thing I want to emphasize is like factories are amazing. I feel like there's this weird thought that like factories are boring places. If your parents make you visit a factory, which I definitely will make my kids do, that's a bad thing. Like this is where all the stuff that is in this room gets made, and they're super important for understanding how these things can even exist in the world. And so, the reason I show this is just like, I love factories. I think they're the coolest things in the world. It's amazing to me that the things we have all around us are made in places like this and then basically delivered to our stores, especially in the middle of the Pacific. Constantly amazes me. And it's just like it's a really important thing. And I think for us to kind of acknowledge that our stuff does not come from thin air, just like the meat in the store does not come out like that. Like there was an animal that was before it. Same thing with your products. They did not just appear out of thin air. There are people and places and factories behind them. And it's really amazing to be part of that process. Oh, sorry, I keep pointing at the screen. Okay, and so I guess I'll stop for a second just see if there's any questions so far.
Can you go back to your factory manager?
Yeah.
What are those machines falling all the way to the right? Yeah.
Oh, these guys?
Yeah.
Those are injection molding machines.
What are these used?
Great question. Almost every piece of plastic that you see around you comes from one of these machines. I didn't bring my injection molding slides. I'd be happy to do that presentation. But basically, there's a giant block of steel, and this negative is cut out of that steel. Plastic is fed into the hopper, kind of over here. It's melted in a barrel and mixed up, and it's injected at high pressure and speed into that steel. And what comes out of that steel is this. So these machines, these particular machines are probably $150,000 a piece, which is cheap, honestly, for those machines. Those actually might be $250,000. The steel molds themselves are probably, for this, you could get them up to like $1 million, depending on how many cavities are in them. And these things can probably make one of these every couple of seconds.
Wow.
So yeah, all the plastic in your life is probably made in one of these. There's other manufacturing processes, blow molding, thermoforming, and all these other things. This actually could be thermoformed, so this is a bad example. Don't quote me to another manufacturing engineer on this. But yeah, that's these type of machines, and these are like small. These are tiny. I used to work in glass manufacturing. I manufactured glass products, and those were like whole buildings. It was basically like there was a vat of lava, and it essentially shot gobs of lava into steel tools, and then something came down and smushed it into the shape. And it's all basically hot lava. It's pretty nuts, which is why manufacturing is fun. Yeah.
Yeah. When you try to design or make one, what are you able to? What the new part? Are you do your own part, and then figure out how you design the thing, or you design the thing and then you do some sort of simulation?
Okay, good question. The question is basically, when you're designing things, what's the process for it? So do you just make a thing and try it, or do you do simulations to see how it'll work? Is that kind of what you're asking?
And I tried to Google something what if they change things as you.
Yeah.
Yeah.
So it's making the same thing as me?
Yeah, like some of copyright stuff.
Oh, knockoffs. Like if someone's trying to knock something off that we're making, or copy it?
Yeah, they try to making it a sport, for example. And then he's trying to make a sport this different. But the other guy who they keep creating things.
Yeah.
I got Google first.
Yeah. Okay. So you're asking if I'm trying to make a fork and someone else is trying to make it, do I look up who else is making them, make sure I'm not copying, or what the competitors are?
That's the first question. And the second question is, are you trying to simulate?
Yeah, simulations. Okay. So yeah, Amazon is your best friend. Basically, Amazon has everyone on it, including all the people copying you and all the people you might be trying to copy. Patents are not as special as everyone thinks they are. They're actually sometimes easy to get around, and companies spend a lot of time getting around people's patents. So the knockoffs question, so if I want to make a thing and I'm worried about someone knocking me off, I'm not sure if that was your question, but I'm going to answer it anyway. Yeah, that just happens. Like, you can't do a lot about it. So at a brand like Oxford or Hydro Flask, we would try to go after Amazon and be like, please take them down. But they just pop up all the time. Crazy, we do crazy stuff. Like occasionally we do legal action in China and there'd be raids, and they would take stuff from the factory. It was nuts. But that's pretty rare. The way to beat knockoffs is to be better and be ahead of them. It's like pretty hard. And honestly, the knockoff, there was one time OXO found someone knocking off a product, and they were actually doing a better job at making it than OXO was. And so OXO found the factory and just contracted them to make the product for OXO. And so they basically they were just like, why don't you just work for us instead of working against us? So there's no good answer on knockoffs. They're really hard, it's constant. I would say as consumers, I beg you to try to buy from the brands themselves. Amazon is a minefield. You can go, if something is like a random fork and it has 15 million reviews, they're probably fake. Because 15 million people don't leave reviews on it. Anyway, and in terms of using simulation, to do product design.
Yeah, you can design something what you do, but to get something that happened in information, you treat it was enough.
Yeah. Okay. So try to answer the question. I think it's how do you simulate basically things happening to prevent bad things from happening, or how do you make sure that you design your product so it lasts? Kind of it.
Yeah.
Okay. So we do use simulation, but a good thing to remember is that computers are not that good. I know they seem awesome, but real objects and real world is actually a lot better. So there's a balance between doing computer simulation and just making a thing and dropping it. So I've spent a lot of time in computer simulations, and they only mimic the real world okay. It's much better to just make parts and then test them. I probably could save a month of time just printing or making a part and testing it versus doing simulation. So, but sometimes it's helpful. It is.
And also, are you trying to get a contact with you first or just
yeah. 3D printing, good question. So, the question is, do we contact manufacturer first, or are we just 3D printing everything?
Yeah.
That is actually a great segue to, yeah, stop print screen. Hohonu, thank you for transitioning me to my slide. Some things you have to use the last slide to do. Like, if I was gonna make 1,000,000 of something, I can't 3D print them. It's slow, it's too expensive, it's not the right material probably for it. But in terms of new and emerging technologies, which helpfully, thank you for all the points I'm supposed to hit beforehand. Here in Hawaii, I actually think 3D printing is a very important technology. And I personally only used it for prototyping things. Like before I talked to a manufacturer, I would 3D print my parts to see what they look like, how they feel, test them. I would never use them for production because our scale was just too big. For Hohonu, which I'll tell you about the company in a second, we actually are using 3D printers for production here. It makes sense, it's the right fit for us, and it allows us to actually make things here in Hawaii, which is really important for us for a bunch of different reasons. So I'm currently at this company, Hohonu, and these are our sensors. There's one of them out in Kapiolani. We are a flood intelligence company. So we make sensors that monitor water level. So that can either be over active water like this. So this is actually at a Waikoloa fish pond in Kapiolani. Or it can be over dry land. It can tell you when flooding is happening. So we were just having a conversation about puna and putting sensors out there to tell when the road is flooding. So we make the sensor and we have a platform that gives you real-time information on water level and flooding. And this is all publicly available. If you go to hohonu.io, you can go to our maps. We have sensors around this state. We're in 18 states total. And this was all kind of the brainchild of Dr. Brian Glazer, who is at UH. Him and Stanley Leo, who are at UH, came up with this idea to try to bring down the costs and democratize access to basically flooding and tides, being more aware of them. So they started Hohonu here in Hawaii and want to keep it here in Hawaii. And our goal is basically to bring down the cost of monitoring flooding and tides so that people can be more aware of when disasters are happening, when their roads are flooding, like so you don't have to drive through them, or emergency management can redirect people. We have big deployments in Florida and Massachusetts, or in South Carolina, which were all affected by the latest nor'easter out there. And so we're really trying to help communities adapt to a changing world by having more real-time knowledge about what's going on in their communities. And in terms of what I do there, so I'm responsible for the mechanical design, the supply chain, and the manufacturing. And when I started the company, full background in the big, beautiful machines over there, giant production, millions of units a year, sometimes injection molding. But coming here to Hawaii, we're a startup, so we're still small, and we're scaling up now. And so my job was to figure out how do we scale up and how can we actually do it here. We were originally working with a company in California to make these, and we actually brought them back here so that we could have control of the production. Quality is super important to us, and we felt like we could pull it off. And so 3D printing has been one way that we've been able to do that. We've been going from machine parts that we order from a supplier in China to 3D printing them ourselves. So we have more control of our supply chain. We're able to kind of make things on demand and make changes on demand. And then we also, almost all the parts you see on this table, except a few, are made here, either with a local supplier. So this comes from Pacific Pipe in Kalihi, and this one is from a metal manufacturer in also Kalihi. And so for us, it's really important to think about how can we build our supply chains locally to build our product locally. And there's tons of benefits beyond just like we believe in building things here in Hawaii. It gives us quality control, it gives us the ability to adapt really quickly and design really quickly. And then on top of that, in terms of emerging technologies, we're not just selling the piece of hardware, we actually don't even sell our hardware. We actually sell the data. So the data is what everyone really cares about. They don't care how we get the data, as long as the thing lasts and is really good quality. They want to know what is the water level and the flooding happening around them right now. And so that's where we really add a lot of value, is not just having a really solid sensor, but doing all the data and insights on top of that. And so I represent just the hardware side of this. There's also embedded systems engineer who does our electronics design and our programming. There's a data scientist who does our data analysis. We have a web developer. We have a few different people working for us on both the digital and the hardware side. I think I have more in here, but I don't know if it's all. Oh, here we go. I didn't even know I had this slide here. That's awesome. This is what it looks like. So all these purple pins are our sensors around Oahu, and this is what it looks like. So in terms of the need, the background on this is that NOAA, not me, NOAA, they only have one tide gauge for all of Oahu. So I think probably all of you know, even better than me, the tide right here is not doing the same thing as the tide up here, or here, or here, or there. The water is different depending on where you are. And so you can see, this blue line is what NOAA predicted would happen, and this is what we actually measured happening. So this is kind of the argument for why this is needed, is because what we can predict is not the same as what we're measuring. So that's where we try to have more. Yeah, I guess this is just CAD. This is what it looks like when I'm at my desk. These are the guts of the sensor. If you are unfamiliar with CAD or engineering, a lot of what we do is 3D design in here. One thing you should know is like what you do on your computer does not mimic real life. As soon as you print something, you'll discover that dimensions are completely different from the computer to the printer or the injection mold or anything else. And that is where engineering and practical experience are really important. Okay, I don't know what just happened, but it's just on its own now. This is 3D printing. Sorry. One thing I just wanted to say about this is, I guess show of hands, anyone familiar with 3D printing? Anyone done 3D printing? Awesome, awesome. There's two different types that I'm kind of now getting familiar with. One is 3D printing for prototyping, where all you care about is making a thing that you can just get off of there. Maybe you're going to make it a different way later. Maybe you don't even care at all. And design for manufacturing on 3D printing, which is totally different. So if you're 3D printing and you don't care about making 100, 1,000 of these things, you don't care about taking off supports and stuff, but designing to mass produce means that all these things just come off the printer and I never do anything else to them.
So when you're using 3D printing just to make a prototype or just to make, say you're making like 100 units but not that many units, maybe 20 units.
Sure.
Would you have to do the manufacturer step or can you do just the prototype step for like 20 units?
That is in the eye of the beholder. So if you want 20 prototypes, go nuts, do the prototype thing. If you think you're going to make that design again later, do the manufacturing thing. Because I basically now just come into my office and I just push a button that says go, and it makes all these things for me. And they're done. That's actually this thing right here. This just comes off like this. I don't have to do anything extra to it, which doesn't sound like a big deal if you've never done 3D printing, but is actually really great. Yeah. Okay. Any other questions on 3D printing? I'm gonna try to stop talking soon. All right. I just want to highlight another local company. So there's a company called Hohonu. And this is a machine I designed for them. Trying to think of the least gross way to get into this, but they're trying to address the cesspool problem in Hawaii, which is very important and also gross. I didn't know before I started helping them. So this is a separator. Not going to get into what that means. But they are trying to use algae instead of septic systems or cesspools to process solid waste. So people won't have to dig into the ground to install septic systems. It's like $3,000 instead of $70,000 to do this. And so their goal is really to help the Pacific Islands with addressing something that's a really insidious problem. If cesspools leak, they kill reefs. Big islands have a big problem with this right now. Really, I wanted to highlight them is just like there's a lot of really cool companies around Hawaii doing stuff that I feel like are just not very well known. And so especially if you're thinking about like a career in engineering or design or any other thing in the future, there's small but mighty companies around the islands like trying to do really creative, innovative things, and it solves local problems, which I think is the coolest part. That's electronics, doesn't matter. I'm gonna stop there, and I'll take questions, and I have a small trivia game everyone can play.
Yeah, how much the thing cost, the prototype cost?
Good question. How much do prototype cost? How much do prototypes cost? Let me see if I can find something. We're gonna have a guessing game. Okay. This part. Who thinks that this costs under $5? Okay. Who thinks it costs under between $5 and $10? 10 and 20? 20 and 30? 30 and 40? 40 to 100? Okay, the answer is $50.
Wow.
$50?
This is $50, and this is cheap for what this is. So I would say this is a relatively cheap part on the whole for doing this. This is machined from a single piece of plastic. It's from a supplier I love, but they're in China. If I got this domestically, probably about $80 to $100. So when you're prototyping things, it's very expensive. I've had prototypes that cost like $3,000, and someone broke it the first time they touched it. It's pretty painful, but it happens all the time. Yeah.
What if you're designing something, and what is the process when you realize you want to design something, but you're not going to be able to do it with a standard 3D printer? I mean, is there a different type of printer you can use, or what's the process?
Good question. There's lots of different processes. That's kind of, this is machined, this is not 3D printed.
Yeah.
So that's one method. The reason spending so much time in the shop early on in my career was valuable is I know how to use all those different processes and how to design for them. So that's one of the things that if you're interested in engineering, it doesn't have to be mechanical, whatever you're doing, do it hands-on. Because you don't know what it takes to do something until you've tried that method. So it's just like an accumulation of experience and vendors and suppliers. And
Like, is there other like types of machines that are not like the standard types? They're like more less frequently used machines.
There's a lot of different 3D printers. It's kind of like 3 or 4 different technologies total.
Yeah.
It just kind of depends. If you have a specific problem, check out Xometry.com or Proto Labs.
Well, how would you summarize like quickly the 4 different technologies of 3D printing? Like, how would you summarize that?
Sure. FDM is basically take a piece of spaghetti and you heat it up and you just build on top of it. You take a single strand of spaghetti and you keep building on top and on top and on top. And that's basically what this is. So if you come up after, you can see it. There's a line between every layer. It's almost like if you cut something into a lot of thin layers and then you just build on top of it over and over. SLA is like a vat of goo, and you divide your object into a lot of layers and it projects each layer onto the goo and it hardens that layer over and over and over and over again. Sorry, I feel like I'm in a test.
2 more.
Yeah, I can do this. SLA is selective laser, no, it's SLS. SLS is selective laser sintering. That is a bed of powder. Again, take your object, cut it into layers, use a laser, shoot it at plastic, move that plastic down, melt more, melt more, melt more.
Okay.
Lasers, okay. And I said a fourth, but I feel like that was a shot.
Maybe it was 3, yeah.
I can stop at 3. There's more. Internet knows more. Computers are good for that. Yeah. Okay.
You mentioned earlier that part was made out of a solid block of plastic that you built out.
Yeah.
And it cost around $50. Was that something that you guys did intentionally instead of like 3D printing it, or?
Yes. So at the time, we were doing machined, and the reason is the printing technology we had was not. It was moisture permeable. So FDM printing, it prints those layers, but if you are a drop of moisture, those layers look like a vast hull you can just walk through. Because there's little gaps between them all the time. So because we're making something that needs to survive hurricanes, sometimes you need solid blocks of material with no gaps in them. We've replaced this with this. This is printed on an SLA machine that we now have, and it's been adapted for printing on that. There's another fun trivia game. Anyone want to guess how much this costs to make? We'll go $5 and under.
What's the material?
Is Tough 2000 from Form Labs. It's kind of like ABS. $5 and under, no takers? Okay. $5 to $10? Okay. 10 to 20? Okay. 20 to 30? 30 to 100? Anyone want to be in that range? Okay. Yeah, $8. Yeah, so not only are we now making this locally, we are saving $42 on it. So it's a pretty awesome win for us.
So you said the expense for that prototype was like $50, but to me it looks like a couple, like maybe a $1 piece of plastic. So like, if it's not the materials itself that's expensive, then what is the I understand there's the cost of operating the machine, but is it really that much, you know?
The answer is yes. It is really that much. It's not $1 material. A lot of people think plastic is cheap all the time, and it's not. It depends on the material. But yeah, I mean, it's the machine. So I designed this file. Someone does not just upload that file to a machine that magically makes it. Someone has to take that file and then reinterpret that file to work on the machine that it works on. So they have to translate it into G-code. G-code goes to that machine. They have to fixture the part correctly. This is at least 2 fixtures, so yeah, this is a fair amount of manual labor actually.
Sorry. So how many different materials can you feed into like a 3D printer? Or like,
Tons.
how much do you use for your materials with this specific?
Like what? How many types of material?
Yeah.
We use 2 different types of material. We use PET-G, and we sometimes use PLA, but mostly PET-G. And TPU. Yeah.
But
Yeah.
you can 3D print any kind of material, right? Like metal and wood and
That is a tricky question. Okay, so this bottle is made out of, I'm going to say, low density polyethylene. Oh, it's made out of PET. I was wrong. This is made out of PET. There are probably thousands of types of PET. So when you're designing things, the type of PET you're using changes by the manufacturing process. It changes by, do you want it clear, do you want it opaque, do you want it to be flame retardant, do you want it to be food safe, do you want it to last outdoors, do you want it to freeze, do you want it to be hot? Like, so in broad terms, yes. If you can melt it, you can mostly do it on a 3D printer. In real terms, the details, the devil's in the details, and like, there's a limited set of the variations on PET that we can actually do in a 3D printer, just because it's a smaller market. Yeah.
Now I'm just asking questions so you don't get bored.
Yeah, thanks.
But what about as far as like metals? Like,
Sure.
there's gotta be some kind of metal 3D printer, right?
Absolutely. They're making rocket engines with it and car parts and airplane parts. selective laser sintering. So what they do is it's a bed of metal, powder, and plastic, and they use a laser, and they shoot it at that, and they melt the metal down. They then take the metal and they put it in an oven, and they bake out all the plastic. And that is how metal parts are made. It's very expensive. Very cool. Yeah. Yeah.
For current capital, how much do you expect to run the company, and then how much they cut over time?
How much overtime?
Now, that you think that's the idea, right? And then the net you have you think how much they cut, and then you buy stuff, and then over time you ask or the number how much they cut, and then 2 years later you get am I lose money or am I win money?
Oh. Yeah. How do you not go bankrupt, I guess, is part of the question. Oh, this is actually great. This is one of my trivia questions. I don't know if we need to do the post-it note things. Do you want to try it?
Sure.
People want points? Are people just here for the points? I heard there's like a point system.
Yeah. If you win, you get extra entries into the raffle.
Okay.
Yeah.
Cool.
Okay.
Let's do so write your name on it, and then maybe last initial, I don't know if it repeats. And then I want you to guess how long it takes to go from the initial concept to production of a butter dish. A butter dish is a thing you put butter on. You can look them up on the internet. I have made one. It's the best butter dish on Amazon, in my opinion. How long do you think it takes? I'm going to say do it in months. How many months does it take to design a butter dish all the way from you kick off the project to your in production finish with it? This will kind of answer, a little bit answer your question. And when you're done, I come up and, I don't know, stick it on the table.
What is the question again?
How long does it take to make a butter dish from the initial time you say, I want to design a butter dish, to I'm manufacturing a butter dish, it's out in the world. Alright, put it here.
That's a 3 point.
Well, I see you went down to the first decimal place. Detail. Yeah, you can just come up and give it to me. I can walk around, I guess. Come to you guys.
Oh, I don't know. You can give it to me as well. Thank you. Do you just have one question?
Yeah.
Oh,
What'd you say?
you just have one question. I gave you a couple.
I can come up with another question. If people are into the game, if it's falling on its face, I'm gonna be.
Yeah.
You got one? You got one? Okay. Thank you. Two different. Who's this one? That's you? I need it.
Oh, I didn't put my name.
Yeah. How am I gonna know who did it? You got it? Great, thank you. How much time? How many months do you go from I design things to I'm gonna design things? Okay. Thank you. Alright, great. Anyone else want to put one more in? Last chance. Okay. Oh wow, you went down. You have like a Gantt chart going here. This is like a full.
Her son is an engineer.
Oh really? Nice. Okay. So I'm gonna read off some of the numbers I got here. I've got 3 months, 5 months, 32 months, 6.5 months, 28 months, 16 months, 18.5 months. 2 to 4 months, 4 months, 8 months, 36 months, 6 months, 10 months, 3.1 months, and 2 months. Okay. If you said 36 months, raise your hand. You're right. 36 months. It took 3 years from the very beginning to the very end. Yeah, congratulations. Yeah.
But what if they worked harder and faster?
I designed the butter dish, so I'm gonna just be straight up insulted by that. If they worked better and faster, it would not matter. And the reason is, the design might take 3 months. The engineering can take 9 months. The manufacturing can take another 12 plus months, because when you start the manufacturing process, you need to cut steel, which is the injection molds. That alone takes a month and a half to 2 months, depending on what you're doing. It can take more. Troubleshooting those molds can take 6 months at least.
Yeah.
And so if you actually do a bunch of design cycles, user testing, if you have problems in production, our average time to make any product at OXO was 3 years. 36 months. Yep, 3 years. So I like to do that one because I hope it emphasizes that like even very, very simple things take a lot of time to do. So when you buy my butter dish, you will say, I can't believe how much time Noah put into this thing, but it is amazing. Yeah.
We get
all
a
right.
picture of it?
Yeah,
I don't have. It's not my computer. If you can pull it up,
What do you look at?
look. Oh, butter dish.
Anybody?
Yeah. Let's see how close to the top I still am.
You can look at my
It's not. It's not. Oh, there it is. Yeah. No, don't do the software version. That's great.
I have that
That's fine. This one.
Oh, I have that.
You have that?
Yeah, I do.
You have the one at Target?
I have this OXO one. Yeah.
This is a butter dish that took 3 years to make.
Wow.
Yes. You should. Ooh, that's not glass. That's plastic.
Oh, it's plastic.
It is plastic. It's all plastic. We made a metal version too. That took a little less time because we already had a lot of it started. But yeah, stuff takes a long time to make. It's really hard, even the simple stuff. And so,
I have a question.
thank your engineers. Yeah.
How do you decide what to make? Because like for this one, it took 3 years to make a butter dish.
It did, yeah.
So how do you decide what to put your time and energy in?
Yeah, that is not my job. But the people whose job it is are called product managers, or it depends on the company with category directors. But that's another place where if you like consumer products or other things, all that stuff, it's like market analysis, like where are the gaps, where are the competitors, what are they doing, like how much could we sell it for? If we sell it for this much, will anyone buy it? Like that stuff is like a whole other discipline. And it's hard, and I think there's a lot of art, not science to it, but more science than I expected. Yeah. Yeah.
I think I missed the first couple minutes. What was your full degree pathway in again?
If you missed it, I can't repeat it. Mechanical engineer.
Oh,
So I'm a undergrad. I got an undergraduate degree in mechanical engineering. Trying to think if there's another trivia. I guess actually, yeah. We'll do one more butter dish trivia. I'm trying to remember the numbers, but I think I got it approximately correct. Okay, that butter dish is now $15. Write down how much you think it costs to make.
Don't forget your name.
I'm gonna phone a friend too to verify this.
Oh, I only do YouTube.
While you're thinking about it,
One
You wanna just give us a
in
snack?
American or in China?
China.
Oh,
US dollars.
Where do we put it?
Oh, sorry.
Well, do us for free.
Let me clean these guys up.
Well, I'm gonna ask more questions. What's the question?
How much did it cost?
How much does it cost the company per unit to? So what I should say is not like how much investment money, just like how much do you think this thing costs to the company versus costs to the customer. Cost to the customer is $15.
Are you talking material, or are you talking about like everything that goes into like labor into designing everything in that material?
You're getting more specific than I wanted to get.
Sorry.
No. What does the company pay to the factory to get this? There we go. So, yeah, I'm not gonna break it out.
As a factory,
Yeah,
is there
how many?
the US
One,
and
right?
China?
What do you say?
The factory is in the US and China.
China.
Is that about one unit or?
One unit, just one. So this one costs $15 to
Are
you.
we done with the games? Should I collect these?
I think we'll be done with the games.
Thanks, Kayla.
We'll see how fast my friend is if she remembers. I think I remember.
I just feel like it's having to get lost. Yeah.
It is marked up twice. Nice. Did you say it's marked up twice?
Yeah.
Great. Do you remember? Do you know by who?
From you guys and then from them.
Yeah.
Target
Yeah.
or whatever. Where was this from?
Very good. All right. Let's see what everyone has. All right. I got $6.32, $3, $7.50, 50 cents. Wow. That's low. It'd be cool. $10 to make, $7, $2.50, three to five. Who wrote a range? That is super inappropriate. Oh, but interesting. But with packaging, $6 to $7. All right, where's Annie? All right, I see you, Annie. I feel like you're not. It's not your first rodeo, but also more specific. All right, $9.63. See, Ko is super specific. All right, let me just double check. I'm gonna try to do it from memory, but just in case, I'm gonna see. I believe it was $3.20. So the closest, I've got a $3.50. Annie's disqualified for the range. That's just ridiculous. A $3. All right, I've got I think $3.50 from Christina. Christina, good job, Christina. Well, I'm trying to see if anyone beat you. No, okay. All right. So great insight. It's marked up twice. So we actually take the smallest margin. Actually, the factory takes the smallest margin. We OXO take the next smallest, and then Bed Bath & Beyond, which is now dead, took the largest margin. So shame on them, or Target. And the reason I like highlighting this is a lot of people. I hear a lot of like, I bet the company pays this much money for it. Like it's like 50 cents. It's not $3.20, but. Yeah, I think hopefully you guys have kind of gotten from this talk, like a lot goes into that, and like kind of everyone needs to make some money so they can stay afloat, and it's a lot less than you think. Factories will operate on like 10% margins on what they sell, so they may only make like 32 cents on that $3.20, right? You know, OXO will maybe make $1 on that, and then Target makes another whatever it is dollars. Well, actually a lot more. But anyway, there's so many people that go into making this stuff and getting it to you, and there's the website, there's the sales, there's the ads, there's the actual material itself. Like that material is extracted out of the ground. The factory is paying someone else to not even extract the material, to compound the material, and they pay someone to extract the material. So what I hope it emphasizes for you is all this stuff you've got comes from a lot of people and places and things. And again, I get a lot of questions about sustainability with consumer products. I worked on it in the R&D area for 3 years while I was at OXO head of class. The best way to think about sustainability is use the least resources to do whatever you're doing. So if you don't like plastic, that's fine. Even if you're using recycled plastic, that's good. And even if you're not, just try not to buy a lot more of the thing. So buy the thing that will last 5 years instead of 2 years. Because if you buy a new thing after 2 years, that's more resources that were extracted to make the thing. So We still need people to make things, but it doesn't mean that making things is bad. I just want to emphasize that because it's good that we have like nice things that are in this world, and there's better ways to make them without making it worse for the world. And you guys can be that. And that's my inspiring speech. Okay. That's all I got.
Okay, let's give Noah a round of applause. Okay. I believe you have some stuff that
Yeah.
people can check out.
Yeah, if you'd like to come up,
All
please
right.
do.
Okay, so we're just gonna quickly wrap up. I'm gonna take a you.
Whoa, wait, sorry, I have an update.
We're just kidding.
Oh, no, sorry, it's a guess. She guessed 290. I think she's wrong.
All right, so if you enjoyed our workshop, or even if you didn't enjoy the workshop, please fill out the last 2 pages of your little packet. So there's a post-workshop survey and also an external evaluator survey that goes to someone else that we don't even see. So the questions that we are going to look at are, as a result of this workshop, you understand something about emerging technologies and what that is? Are you maybe more likely to pursue emerging technology pathway? That doesn't necessarily have to mean strictly engineering, but maybe even something adjacent. I see how emerging technology fields are applicable to Hawaii, which he definitely answered. And I understand what emerging technology jobs are available, right? You can work with him. And I see how indigenous knowledge can be applied in emerging technology fields. The technical topics that we were going over today were interesting. Some of you got sucked in even though you're unintentionally here, so just keep that in mind. Work at this partner or company or organization connects to issues of concern and relevance to people in Hawaii. And non-technical skills is teamwork, collaboration, communication are relevant to work at this company / partner organization, and they were addressed today. Based on what you heard in today's workshop, do you think you would be interested in applying for a summer internship? Do you want to practice real fast, maybe 1 sentence what the internship will be about?
Sure, I'm not sure yet.
Sounds great.
But we're going to do it in 1 of 2 domains. Either it'll be helping on the hardware side, so it'll be helping with design, fabrication, potentially some of the manufacturing stuff, or it'll be on more of the data science side. So that would be helping with either doing some analysis. That's what our intern last summer did. Dylan, he was great. He did some analysis for us. Potentially, we would look at some other ones depending on the need. We gotta see where we're at this summer, assuming we're still here.
Awesome.
We will be.
Okay. And then if you have any other suggestions of topics or companies you'd like to see, please let us know. Also, I was just notified, I think we had a printing error, we're missing a page for the consent. If you could just print and sign your name on the top of any part of that consent form, please do so. So name, first name, last name, signature, and date, just so I don't get sued. That would be great. And then after that, thank you very much for spending a very important time of your day here with us and with Noah. Please feel free to come up and you can ask him questions. You can touch, listen to things. And then just wanted to kind of let you know that again, we have workshops pretty much every single week of this semester. So we have a couple more coming up. We have this QR code which I'll leave up here for you guys to scan so you know exactly when those are. We will always have food. Everything that you do, sign in, the consent form, the survey, not the consent form, the survey, the games, those all count as raffle entries into the $100, which you will get after the semester is over. And then again, next semester, Noah will be hosting a site visit to his site, so you can learn more about what his company and his team does. And yeah, and then maybe you guys are interested in the summer internship program. If you have any questions, can you guys raise your hand, the interns from last summer? So yeah, there's 3 of you. Where's Annie? Oh, okay. Annie was the range girl. She was also one of our interns this past summer. So if you have any questions, you can definitely ask them. They're also peer mentors, so they have to answer your questions. Okay. Thank you guys very much. Feel free to grab more food. Thank you.